Hello everyone, welcome to this lesson. I'm the lecturer Leon. In this lesson, we will use an example to demonstrate how to use Inovance H5U88 PLC to perform simple control of servo motor or stepper motor with a pulse interface. We use Inovance H5U88 PLC for the controller, Inovance SV630A for the servo motor, position control mode for control mode setting. The electronic gear ratio is set to 10,000 pulses per rotation, and the interface adopts the form of pulse plus direction. Let's look at our PLC I/O allocation. The function of the program is to press X1 once, and the motor will rotate 360 degrees clockwise. Press X2 once, and the motor will rotate 360 degrees counterclockwise. X3 and X4 are manual clockwise and counterclockwise rotation. Press X3, clockwise rotation, release to stop. Press X4, counterclockwise rotation, release to stop. Use Y0 output pulse and Y1 for direction control. Now we open AutoShop software. Click File to create a new project. We set a name to the project, such as Servo. Select the save path. Editor, select ladder diagram. For equipment selection, we select H5U series. H5U8 PLC. Click OK. We first test whether the computer can be connected to PLC. Click Tools and Menu. Click Communication Settings. We use Ethernet to connect the key. Select Ethernet as communication type. Click Search. See if we find PLC. Double-click the line of PLC after we found it. Save the IP address to the project. Click OK. Using PLC to control the servo motor can be divided into two steps. The first step is motion control axis configuration, and the second step is motion control program writing. We first configure the motion control axis. After entering the development environment, find the Configuring a Motion Control Axis in the Engineering Management window. Right-click Add Axis. Here, the axis of axis 0 is added. Double-click to enter the settings of S0 axis. Let's make basic settings first. We choose the local pulse axis as the axis type, and Y0 and Y1 as the output device, which corresponds to the output of Y0 and Y1 ports of PLC. Click the unit conversion setting and select degree for the user unit setting. The meaning of degree here actually is rotation, not angle or radian. In the motion instruction of the subsequent PLC program, 1 degree means 1 clockwise rotation. -1 degree means 1 counterclockwise rotation. For the pulse number of every rotation of motor encoder, We first check the decimal to display pulse number. According to the gear ratio setting of our servo motor, we fill in 10,000. Choose not to use the transmission device. Input 1.0 degree, which indicates that after the PLC outputs the number of pulses of one rotation of the previously set electrode encoder. That is, after 10,000 pulses, the work table rotates 1 degree. That is, it rotates 1 turn. Click Mode Parameter Settings. Select Linear Mode. Don't check the software limit. For the preset settings for software error response, the shaft speed is set to 50. These settings are reasonable for this program. For example, the maximum speed is set to 50 degrees per second, corresponding to 3,000 revolutions per minute, which is exactly the rated speed of the motor. Output setting. The output mode is set to pulse plus direction. That is, Y0 outputs pulse, and Y1 outputs direction control signal. Homing setting. Since we don't have homing function here, we can skip this part. After configuring the motion control axis, we start programming in the second step. Under the programming block for engineering management, click Make to start writing the ladder diagram program. We find the MC axis control pulse output in the toolbox window. Click on the basic instruction. Add the enable instruction MC power. We use M8000 contact. M8000 means that it will remain on as long as the PLC is running. Add the axis just configured to the axis pin of the instruction. Add the X1 contact to axis 0. Select the rising edge for pulse. We add the axis relative motion instruction. Fill in axis 0 in the axis relative motion instruction respectively. The running distance is E1 rotation. The speed E1 means 1 rotation per second. The acceleration is E50. In the same way, add the rising edge contact of x2. Fill in E1 in the moving distance, which means counterclockwise rotation. Speed is E and acceleration is E50. We add the JOG instruction to keep it enabled all the time. Set the parameters of the instruction. Clockwise rotation is x3, and counterclockwise rotation is x4. Set the speed to 1 rotation per second and the acceleration to 50. After programming, we compile and download it. The program is written correctly and has been downloaded to the PLC. Click to run the program. Perform monitoring of the program. Turn on the camera and see the running effect. Press X1 once for about 1 second, and it rotated for 1 circle. Press X2 once, and it rotated in another direction. Let's test the JOG function again. Press and hold X3. The motor rotates clockwise. It stops when you release. Press and hold X4. It rotates counterclockwise. It stops when you release. It means that the program has achieved the function we want. In the subsequent practice, You can modify the configure parameters and specify parameters to better understand the meaning of them. In this lesson, we focus on how to use Inovance H5 UPLC to control the servo motor with a pulse interface. Finally, I would like to leave a question for you. Are the settings and procedures of this PLC applicable to other brands of servo drivers? Are they suitable for stepper motors? If it's applicable, what are the requirements for the driver of the motor? That concludes this lesson. Thank you for listening. See you next time.